This conference will now be recorded.
Okay, so good morning everyone. Welcome to the Snowflake course. So today I'm going to give the demo part. Okay, so what is Snowflake? Why we are using this? So we already have on-premise data warehousing tools like Oracle we have, and SQL Server we have, like many other databases are there. So why we need to use only Snowflake? What are the different unique features that we have here? So how it is faster than other databases, that thing we are going to see. Okay, so before getting into that one, I just wanted to tell you like what is Snowflake first of all. Okay, so I think everybody is having some idea on cloud, right? Basic idea at least. So uh, every cloud offers three different types of services, right? SaaS, PaaS, IaaS. One second, please. Yeah, sorry. So every cloud provides three different types of services, right? So that is software as a service, that is SaaS, platform as a service, that is PaaS, PaaS, and third one is IaaS, that is infrastructure as a service. Okay. Now Snowflake come into which category? Is it SaaS, PaaS, or IaaS? Which one? Which category it fall in? So it is a software as a service. So you guys know, like SaaS is nothing but it's end user service, software as a service. Snowflake is a third party company, okay, and they're deploying their services into public cloud. They are AWS, Azure, and GCP. You guys are able to follow me? Snowflake is a third party company, but they are deploying their services into public cloud, that is AWS, Azure, and GCP. Okay, so what language they are using to manage all these things? They're simply using ANSI SQL, that is normal SQL, that whatever we are using in Oracle and our other traditional databases. Okay, so what activities it can do? What are all the tasks it can perform? So mainly the main use of this Snowflake is database. It is a database actually. Okay, it can perform ETL activities also up to certain extent. I'm not saying it's a pure ETL tool, but mainly it is used for a database. Okay, so we don't have like drag and drop kind of components in Snowflake, like Informatica we take. So Informatica is a pure ETL tool. There to manage all your loads and all, we have to build something. We have to drag and drop some components there. So inbuilt components are there. But in Snowflake, we don't have such kind of things. Everything we have to manage through SQL only. So that's the reason why I'm telling it's not pure ETL. It can manage the ETL activities up to certain extent. Okay, so the main use is database. You simply you simply insert the data into the tables. You simply create the tables and you do whatever you want, or you create views and you can start querying the data from there onwards. So the main use is database. Okay. Okay. So what is the traditional data ETL architecture that we have, and where exactly our Snowflake is fitting in? Okay, so let me explain the legacy data landscape, that is traditional ETL architecture. So you guys know we get the data from different sources. ETL takes the input from the different sources. Input means it is data. Okay, so the data may come from databases, OLTP databases. The data may come from enterprise applications. Okay, it may come from third-party services, or sometimes it may come from web applications, or some other thing applications are also there. So we simply accept the data from any of these sources, and we do extract transformation and loading, ETL. Okay, extract, transformation and loading we do. Okay, and after that we simply load the data. We build the enterprise data warehousing here. After loading the data into the finance tables, we build EDW, that is enterprise data warehousing. We build the fact tables, we build the dimension tables, and we build on top of it, we build small data marts to achieve to do the reporting on top of it. Okay, so that is nothing but you're constructing a data warehouse here. You're preparing a data warehouse here by using fact and dimension tables. Okay, or of course sometimes databases also acts as a data lakes also. So data lake is nothing but where you can store. It's not a data warehouse where you can store your historical data, I can say. You can store normal warehouse data, and you can store even semi-structured data as well in the data lake. Okay, so once you build this data warehouse, on top of that one you have to build data marts. Data marts is nothing but, see, this is enterprise level data, right? So but I wanted to create one schema. Okay, one schema means like we have one fact table which is surrounded by dimension tables. Okay, I have to prepare one schema or one data mart which is related to only HR, which are related to only financial, or which are related to only supply chain. Like that I have to build small data marts. I don't need to access all these fact tables and dimension tables whatever I'm building in EDW. Okay, and those data marts I'm giving it to the reporting people, or directly EDW you can share with BI people also, no problem with that. But generally we follow is we build the data marts and we share, we give that access to the BI people, that is reporting people, I can say. Or sometimes what happens, these people are data science people actually. Okay, what they do is they don't access the data from enterprise data warehouse. They directly access from data lake. Why? Because they don't accept updated data and deleted data. Okay, they accept the historical data. They wanted to analyze what has happened at particular point of time. They need everything from scratch. So that is the reason why we give this data lake access to the data science people. Okay, so this is the modern, this is not modern, I can say. This is general architecture of the ETL, I can say. Now, where Snowflake is fitting here? Now, which place that we are going to use this Snowflake? Okay, so that is what I'm going to show. This is the one Snowflake is fitting in. Okay, I told you, right? Up to some extent, Snowflake acts as a ETL tool. Okay, it accepts the data from different sources, all different sources. It accepts the data from any of the sources. It may be a OLTP, it may be enterprise application, it may be a third-party service, anything. And we can build whatever the data warehouse I was talking. That data warehouse I can build in a cloud, not in on-premise. Okay, or otherwise I can build data lake also inside the Snowflake. My Snowflake acts as a data lake also. It's not a data warehousing. It can also act as a data lake. Okay, on top of that one, if you want, you can share that data, enterprise data warehouse directly to the reporting people. That is also fine. And or otherwise, on top of it, you can build small data marts. Okay, financial related data mart and HR related data mart, supply chain related data mart. Like that, we can build different data marts on top of it, and we can give it to reporting people. Or you can even share the data to other data science people also. You directly we can do that one. Okay, so all these activities can be done by Snowflake here. So that is the reason why Snowflake has become popular nowadays. Okay, so I'll give you some time to ask the questions actually. So hold on your thoughts for some time. uh, let me finish this basic thing, and I'll come back to your questions. I'll clarify all your doubts. Okay, now what people are doing with the Snowflake now, what kind of activities they are doing here. I told you a similar thing here. So but the difference between the previous slide and this one is, so we have for every ETL tool, we have staging, right? So extract, transformation, and loading we are doing right in ETL tool. So for extracting the data, like we use some internal things, and we have to transform the data. So while transforming the data, we have to store the data somewhere in staging location. Okay, that staging we have in Snowflake. So sometimes we call it as a data lake also. Okay, so why we are taking this, why we are using this Snowflake as a like staging location is, so generally for faster access. Okay, we store the data in NoSQL databases. Why? Because that is not columnar approach. That is sorry, that is not row level approach. That is columnar approach. All NoSQL databases follow columnar approaches for faster accessing of data. Snowflake also follows the same thing. It's not row level accessing kind of data. It's a columnar data accessing thing, database tool, I can say. So you can retrieve the data in a very fast manner. So my Snowflake can act as a staging location for some of the applications. Okay, for faster retrieval, I can say. Or you can build data warehouse also on top of it. Once you stage the data, you can even build the warehouses. Okay, so on top of that one, if you want, you can have data marts. Okay, small data marts, and you can give that access to the reporting people. So one more thing is, what other thing that we can do with Snowflake is, we can share the live data, whatever we are getting from the source, to the report to like other users or data science people, I can say. Live data we can share. Live data in the sense, let's say for example, consider this as a source. Okay, so today I have loaded 100 records into my data warehouse, and I've given access to these people. Okay, so after some time, after 1 minute or 2 minutes, some modifications are happened from the source side. Modification is some records got inserted and some records got modified, I can say. So whatever that records get modified, that live data directly I can share with these people. That we call it as sharing concept in Snowflake. Okay, the moment you load the data into the table, into the enterprise data warehouse, then that data can be available to these people. That is also possible with Snowflake. That we call it as sharing. So no other database is having that kind of feature, but only Snowflake is having that feature. Okay, so that is the one of the use case with Snowflake. Okay, now what are the benefits that we have? What are the benefits that we have with Snowflake? First one is performance. Since the data is in cloud, okay, and since the data that we are storing in a columnar format, the performance is much better than other traditional databases. Even you can compare the performance with Hadoop also. So you guys know Hadoop. What is the use of Hadoop? So to process the huge volume of data, with like within no time, we use Hadoop and Spark. Okay, and even you can compare the performance of Snowflake with Hadoop also. Even it is faster than Hadoop, I can say. Okay, that is one benefit. And concurrency. So let me take an example of Oracle or other traditional database, an example here. So if the number of users are increasing, the people who are accessing the databases are increasing, then the database performance will get down, right? Or if the more number of queries are running in the database, then the performance will get degraded, right? That's where database administration is to monitor continuously what queries are running, and what developers are running continuously, what kind of queries they are running, and how long they are taking time, and those things, those measures they used to monitor, right? Okay, that means number of queries are increasing, or number of users increasing that are accessing the database, then the performance will get degraded there in traditional databases. But whereas in Snowflake, even 100 people or 200 people or 500 people or 1000 people are accessing the database, no problem at all. any number of people can access the database simultaneously, and the performance will not degrade at all. That is the very, very, very beautiful concept in Snowflake. Okay, we have virtual warehouse concept in Snowflake. With that, we can achieve this benefit. Okay, so let's say, for example, today, like at 9 o'clock, one user got logged in, and the performance was very good. Okay, and let's say after some time, after 9:30, generally business people used to log in. Okay, and 100 people came in and they started querying the data from the database. At 9 o'clock, what was the performance you got for one user? The same performance you can see for 100 users also. Okay, there is no degradation in the performance even when more number of people are accessing the database. That is one good thing. That is about the concurrency. Concurrency means parallelism. Okay, and elasticity. So this is nothing but generally in ETL tools, the loads are happening, right? We do the bulk loading, right? Bulk loading means at 12 o'clock or 1 o'clock we used to start the loads, and it will take some good amount of time, like 3 hours or 4 hours or 5 hours, and loads will get completed. On top of that one, we build the enterprise data warehouse. Okay, so sometimes, not all the time, from 1 o'clock to 2 o'clock, you may get the data from most of the, I can say, you're getting more data. From 2 o'clock to 3 o'clock, you're getting very less amount of data from the source. Okay, then in that case, my Snowflake can manage that loads. If the load is more, then it can accommodate or it can spin up more number of clusters between 1 o'clock to 2 o'clock. Between 2 o'clock to 3 o'clock, if the load is less, then it can manage the number of servers. It can spin down the number of servers. Okay, that everything can be managed by Snowflake itself. You don't need to involve there, and you don't need to intervene there. You don't need to do anything from your side or admin side. That load balancing can be done by Snowflake itself. So Snowflake has that intelligence to manage that load. That's what I call it as a elasticity. Elasticity is nothing but you can increase the number of servers, you can increase the number of clusters whenever the load is more. You can decrease the number of servers whenever the load is less. That's what I call it as a elasticity. Okay, so that can be managed by Snowflake itself. Okay, and one more thing is minimal configuration and tuning. So on-premise, in the case of on-premise, we need to have, if at all, if you want to store some data like 1 TB or 2 TB of data, then you have to purchase one server. Okay, for that you have to do some planning. Okay, so in future I'm going to get 2 TB of data, so I have to purchase, like for backup purpose, I need to purchase like 6 TB of data or 10 TB of hard disk. So I need to have some RAM for that one to manage my loads. Okay, 128 GB RAM or 512 GB of RAM. Okay, or something, some kind of planning you have to do. Okay, or for you have to install some OS into that server, and you have to maintain separate room for that one, and you have to maintain AC for that one, and you have to maintain continuous internet for that one, uh, and you have to maintain continuous power supply for that one, and somebody has to monitor that server performance every time, whether it is CPU utilization is 100% or it is utilizing as per the expectation or not. Those kind of things are administration kind of things, right? Okay, so in case of on-premise, you have to manage all those things, and 24 by 7 you have to manage the administrators, and three people has to work on that one 24 by 7. Three people mean three shifts people has to work on that one. 8 hours, 8 hours, 8 hours, 24 hours, somebody has to monitor that. But in case of Snowflake or in case of cloud, we don't need to have all those things. We don't need to install any software, and we don't need to maintain any server room, and we don't need to maintain any ACs, and we don't need to maintain any internet and power supply, anything. Nothing is required here. You just need to create an account with Snowflake and start using that one. That's it. That is enough. No administration is required here. No configuration is required here. Okay. And no tuning also required here. Okay, of course, some minimal tuning is there. I accept that. But whatever the tuning techniques that you're following in the traditional databases, those many tuning techniques are not required in Snowflake. Like to improve the performance, generally we create in Oracle indexes, we create partitions, and we load the data into temporary tables instead of subqueries. Okay, and all those things we follow. Okay, and those things are not required in Snowflake. By default, whenever you store the data in Snowflake, that stores the data in the form of partitions. Whenever you query the data from the Snowflake table, automatically it retrieves the data from those partitions. It can directly go to the partition and it can retrieve the data. So that's the beauty of Snowflake here. That means what I wanted to say here is there is no administration kind of thing in Snowflake. Okay, administration means server maintenance and physical server maintenance I'm talking. Okay, administration means creating users and giving access, not that kind of administration I'm talking. Okay, physical server maintenance, physical server administration is not required here. Okay, and for working with Snowflake, you don't need to have any special skills here. Special skills means you don't need to learn any programming language, and you don't need to learn any special kind of language to manage the Snowflake. If you have SQL skills, if you know SQL queries, that is enough to work with Snowflake. That is more than enough. Sometimes Python is required, of course. Why? Because to automate the things, Python is required here. Python scripting, you don't need to be an expert in Python here. Okay, so whatever the basic knowledge that you have in Snowflake, that is enough. Scripting level knowledge is more than enough to manage the Snowflake. Okay, those are the benefits that you have with Snowflake. Okay, and who are all the customers that are using this Snowflake? And you guys know some of the famous companies are there here, like Sony, like Fitbit, and all these top companies are using Snowflake nowadays. Why? Because this is modern data warehousing, I can say. Okay, they process huge volume of data, and Snowflake can manage those things. Okay, so almost 4,000 plus customers are there throughout the world. Okay, now it would have increased more than that. I'm not sure the exact count, the customers count, but it should be more than 4,000. Okay. Okay, before getting into the architecture part, so you guys have any questions? If you have any questions, you can ask me.
Channa,
On
I have a
Yeah, go ahead.
Channa,
so
on a scale of 1 to 10,
Mhm.
how much SQL knowledge is required for Snowflake?
Mm, I can say here PL SQL knowledge is not required. Only basic SQL is enough. I can say 6, 1 to 10. If you have
Okay.
60% of the knowledge in SQL, that is enough.
You mean there is no requirement of storage procedures to be written
No,
in this?
no, not required. So, of course, stored procedures are there, but we don't write that in SQL. We write that in JavaScript language actually.
Okay, we need to have Java and
Yeah, and
Python,
we need
both of them
no.
basic knowledge.
Yeah, that is not actual JavaScript that we are using in procedures actually. That is JDBC language.
Okay.
Okay, and you don't need to learn any JavaScript, pure JavaScript there. So hardly you'll be having 20 functions there, 20 methods are there. You just need to understand those 20 methods. That is enough to handle your requirement.
Okay. And in our course, that will be part of our course, whatever we are
Yes,
going through. Okay.
yes.
And
And if you are a Java developer, of course, even Snowflake started giving support for Java as well. You can write the procedures in pure Java also. That is also fine.
And while migrating data, or else while trying to migrate whatever Snowflake data we have stored to any cloud, do we need to write any JSON using Visual Studio to ensure that it maps or it migrates?
Um, why do you migrate the code to cloud? Snowflake itself a cloud, right?
Yes, but whenever we need to retrieve any data, for instance, in any EC2 whatever we are working on, if we need
Mhm,
to extract data or if we need to call the data from Snowflake, there
mhm.
should be some connectivity, right? When
Of
we need
course,
to. So,
of course. We have terminals for that one. We have SnowSQL terminal and we have WebUI and we have DBR also. So many
okay,
clients are there to retrieve that data.
okay, and that
I'll
should
discuss
be
those.
installed on both, or only that is something which we need to install it
We
on
have to
our.
install it in our machines.
Okay,
That is simple thing only. See, let's say for example, so I have WebUI here. Let me show you that one.
okay,
See, this is the WebUI actually. So let me try to log in here. So if I say select star from EMP, then I can able to get the data directly here. So let me show you. Let's say for example, XML raw. This is one of the table. See, I'm able to get the data. You don't need to install anything here. I mean, uh, if you are using WebUI,
okay.
okay, you have terminal here. I can say this you need to install. Okay, this is
Okay,
very easy thing. Like it won't take much time. Hardly 2 minutes it will take to install and configure your account and everything.
okay,
So they have given these clients actually to access your data. That I'll show you in some time, of course.
sure.
Yeah. Any more questions from anyone?
So you
So
told
based
about
on this,
real-time data sharing, right? From
Yeah.
source to end user. So
Yeah.
how it will be automated?
So automated means I told you right. Once the data has to load it into EDW, that is tables. Then once you get the data into the tables, then live data can be available to other people who are using the table. If you share with other people or other accounts, then live data can be available to those people.
So my question is, suppose if you take a AWS S3 bucket, okay.
Okay.
So every minute I'm getting the new
Okay.
data.
Okay. Okay. hmm
So how you can reflect to the end user?
Okay. So we have in Snowflake snow pipe concept.
Ah,
Okay. So what does that do is whatever the data that you're placing in S3 or whatever the data that you're getting from other sources into S3, and your snow pipe detects that files automatically and it loads the data into your tables automatically. It runs the copy command in the background. So that
okay.
is for continuous loading.
Mhm. Okay. So we are not scheduling anything here, right?
No,
Any.
we don't need to schedule that. Yeah, we don't need to schedule that.
Okay.
Okay. Any more questions before move on to architecture part?
so what is the role that we call here? Like, I mean, suppose if a database maintenance, we call it as a database administrator. If it is SQL developer, we can call him as a SQL developer. Something like, for if we are working on a Snowflake, for the sake, I mean, whatever we are going through, I mean, we come under a database administrator part, or we come under the Snowflake
Developer.
So we call it Snowflake developer. Okay.
Yes.
So Python and Java, you said somewhere Python and Java, those are just command go. We don't need to really to be expert on those things. Right?
Yes. To automate few of the things, we generally use the Python. Okay, let's say for example, let me take one use case here. So to utilize the parallelism in Snowflake, generally we don't load bigger files in Snowflake. We always go with smaller files only. Okay, let's say for example, today I got 1 GB file from my source. Okay, I am not supposed to load 1 GB file directly into Snowflake. Okay, so we will not be utilizing any parallelism there. Instead of loading 1 GB file directly into Snowflake, what I will do is I will divide that file into 10 different parts. File 1, file 2, file 3, file 4, like that. So to do that activity, Python is required here. Snowflake cannot divide that file into multiple parts. So that what I will do is, using Python or using pandas concept in Python, I'll divide, or every 5 million records I'll try to create one file, or every 10 million records I'll try to create one file, or for every 100 MB file I'll divide that 1 GB file into 100 MB files. Like that I will divide into 10 different parts. Then if you try to load the data into the Snowflake, then you're really utilizing the parallelism process in Snowflake. Within no time you can process that. So that kind of activity you're going to do with Python.
Okay.
Okay, and one more use case is, let's say for example, you're migrating the data from Oracle to Snowflake. Okay, so you wanted to connect with Oracle database through Snowflake. What we can do is we can use Python, and we can connect it to the Snowflake. We can connect it to Oracle, and we can connect it to Snowflake also. We can create a connection between these two databases. Python is just like a mediator between these two databases. We can generate files from the Oracle, and we can put it into the stage location in Snowflake. So that is also one of the use case where Python is useful. Okay. So any more questions? Okay. So let me continue the architecture part. So the Snowflake architecture is divided into 3 different parts here. Okay. One is storage layer, second one is compute layer, and third one is cloud service layer. What are all these 3? Okay. Let me explain one by one. So whatever the data that you're storing in Snowflake tables, okay, that we are storing it in a storage layer. What is the storage layer? Where exactly this is storing the data? So do we have any separate database for Snowflake, or it is using any cloud provider storage part? Okay, it is back end Snowflake. We don't have any dedicated database for Snowflake. Do remember that. Okay, and what it is doing, then how it is storing if you don't have any database separately? Then if you deploy your services, or if you choose your cloud provider as AWS, that is Amazon Web Services, then Snowflake people are storing the data into Amazon S3 buckets. So they are utilizing that storage part, and they are storing the data into S3 buckets, and they are not showing it to us. They're simply saying it as a database. Okay, and if you choose cloud provider as Microsoft Azure, then they are storing your data in the backend in the blobs, Azure blobs. Or if you choose cloud provider as GCP, that is Google Cloud, then they are storing the data in Google Cloud file formats. They're storing in they're utilizing their file system in the backend. So like that, whatever the cloud that you're choosing, based on that one, they're simply storing the data into that public clouds. Okay, so at any point of time, you can increase the storage and you can decrease the storage here. On demand basis, if you're storing 1 TB of data, on demand basis, you can have the storage part. Or upfront, if you want to buy any 100 TB or 200 TB of space, then of course you can buy that one also. Or on demand basis, if you're storing the data, then of course you can store the data like that also. Nobody will stop you to store like that, and nobody will put any restriction to store the data here. And whatever you are storing the data, you pay only for that one. That's it. Pay per use concept here. So let's say, for example, you're storing 1 TB of data. Okay, then pay only $25 for that one. Per 1 TB, uh, if you purchase the storage upfront, they are charging $25. That's it, per month. You have to pay rent upfront. If you buy that one, if you buy that storage part, then they are charging $25. Okay, on demand basis, if you are going, then they are charging nearly $45. And at any point of time, you can increase the storage, you can decrease the storage. That depends on administrator or the developer, whoever is storing the data. Okay, so that is about database storage part. And they don't have any dedicated storage here. Snowflake people doesn't have any dedicated database system. Okay, if you create account with Snowflake with the cloud provider as AWS, then indirectly they're storing the data into AWS S3 bucket. That's it. Okay, and whatever you're storing, you pay only for that. Okay, on monthly basis. That's it. That is about storage layer. Okay, and what about compute layer here? So compute layer is nothing but it's a mediator between user and the database. Mediator means, like, let's say for example, I'm issuing a query like select star from EMP. Then somebody has to go and get the data right from this database storage. Some hardware has to run right in the background to get the data. That hardware is nothing but your virtual warehouse. This is nothing but your hardware which is getting the data from the storage layer, and it gives and it takes the data from the database storage and it give it to the user, whoever is querying the data. Okay, and this one I told you, right? At any point of time, you can scale up your virtual warehouse size, and at any point of time, you can scale down your virtual warehouse. You can increase the number of servers, or you can increase the number of clusters at any point of time, irrespective of the storage. Irrespective of the storage, you can increase the virtual warehouse size. Okay, you can have 10 number of servers also, you can have 16 servers also, you can have 32 servers also, you can have 40 you can have like 64 servers also. So to multiples of 2, you can increase any number of servers here. This is nothing but your physical hardware, I can say, which is useful to get the data from the storage layer. Okay, here this virtual warehouse layer and the storage layer both are completely decoupled. They are nowhere related to each other. The only task or the only functionality of this virtual warehouse is just go and get the data from storage layer. That's it. Irrespective of the storage, you can increase the virtual arrow size, and irrespective of the storage, you can decrease the virtual arrow size also. Okay, both are completely decoupled here. But whereas in Oracle or other traditional databases, then they are tightly coupled actually. Okay, this is about compute layer. Here also, how long you're running your queries and how long you're running your queries. You pay only for that one. Let's say, for example, I ran my query for 1 minute. You pay only for 1 minute. Of course, that depends on the size of the virtual warehouse. Okay, I'm running my query for 1 hour continuously. You pay only for that one. That depends on how long you're running your queries. The billing part completely depending on the size of the virtual warehouse and the queries, how long you're running. Only those two parameters you have to consider here. Okay, that is about compute layer. And third one is cloud service layer. And authentication and access control can be controlled by cloud service. Authentication and access control is nothing but, let's say, for example, when you create an account with Snowflake, you are giving username and password. Somebody has to authenticate, right? That one username and password are correct. So that part can be controlled by cloud service layer itself. Okay, and we have infrastructure manager here. So that is taking care of all these things. Okay, and we have optimizer also, which takes the decision whether to get the data from the cache or to get the data from the database. So whatever the query that you're giving, that it will first go to optimizer. Then optimizer will decide whether to get the data from the cache part or to get the data from the this database storage. Okay, that is about optimizer. And what about metadata manager? I told you, right? So in traditional databases, if you want to know the count of a particular table, then you have to run a query select count of star from table. In Snowflake, you don't need to run that query. The counts and the sizes and the micro partition related data, everything will get stored in metadata here. See here, I'll show you the same thing here. Okay, let me take one big table here, that is shared database. So this is schema, this is database, this is schema actually. Okay, so let me take this schema and I have so many tables inside this. Okay, see here, when I put my cursor on the table, so right side you can able to see number of rows and the size. How you're able to see that? This everything information that you're storing in metadata. Okay, here also, let's say for example, I'm taking this schema. So I have customer table which is having almost 101 GB. 101 GB space it occupied almost. Almost 150 billion records are there in the table. Without querying the table, how Snowflake is giving that count? That means we are storing that count related things, everything in here in metadata. Okay, and one more thing is security. Security is nothing but in like just like in other databases, here also we can create users. Okay, and we can control the privileges and the objects. Let's say for example, this user has to have an access only on this particular tables. Then you can control that with the help of security. Okay, so this is nothing but your architecture part. So basically this architecture contains three different parts. One is storage part, second one is compute part, third one is cloud service part, global service layer. Sometimes we call it as a global service layer. This one is query processing layer. This one is storage layer. Okay, now the same thing I have given here. So we have centralized storage here. Okay, this is nothing but your centralized storage. One storage is only one here. At one place you are going to store all your data. Okay, on top of it you can have any number of virtual warehouses. Okay, and I can create one virtual warehouse and I can give the access to data loading people. I can create this virtual warehouse and I can give the access to marketing people, and they can get the data or they can access the data through this virtual warehouse only. Okay, and I can create independent virtual warehouse and I can give access to finance. I can create this virtual warehouse and can give it to testing people. So dedicated virtual warehouse I can maintain here to each and every department, I can say, to each and every group of people. Okay, and every virtual warehouse can access the same storage. I told you, right? It's a centralized storage actually, and every virtual warehouse can access that particular centralized storage parallelly. Okay, I'll anyway discuss that one in some time. Okay, now we have shared nothing architecture and shared disk architecture. Okay, now Snowflake come under which type of category? Is it shared disk architecture or shared nothing architecture? What is it? Which category is it falling? Okay, so before that one, let me explain what is shared disk architecture and what is shared nothing architecture. Okay, so let me take an example of Oracle here. Okay, Oracle, you will be having only one storage. You'll be having one server. Inside that one, you'll install that Oracle database. Okay, and that is nothing but your centralized storage, I can say. Okay, and on top of it you can increase the computing power. Computing power means if you want, you can have more RAM size to access this particular database. Okay, and in Oracle, if the more number of people or more number of users are trying to access this particular database, then your database performance will go down. Then you have to increase your computing power. Computing power means RAM size or whatever you'll increase. Storage is only one, but you can increase your computing power on top of it. Okay, that is nothing but shared disk architecture here. Okay, all computing or all hardware, whatever you're using here, that is accessing this shared disk. Okay, and the only advantage with this architecture is data maintenance is very easy here. Why I'm saying data maintenance is very easy here? And whatever the data you're storing in this database, you're storing in this memory only, in this system memory only. Only in one system or only in one database you're going to store that particular data. That is only the advantage with this architecture. And coming to shared nothing architecture, if I take Hadoop an example here, in Hadoop you'll be having clusters. Clusters, right? Cluster means like one node, one physical hardware, one physical system. Okay, there if you install like Hadoop in any of the systems in cluster, if you create one cluster, then what you're going to do is you're going to store the data not in one particular system. You're going to store the data in different systems to avoid system on failure. System on failure means, let's say for example, you're storing the data only in this system. If the system goes down, then what happens? You cannot able to get the data. Then to avoid that one, what they do here in this shared nothing architecture, they store the data in this system also, and the same data they are going to maintain in this system also. That we call it as a replication, data replication. Okay, if this system goes down, they can get the data immediately from this system. Or if this is also going down, this also goes down, then immediately they can get the data from this system. That kind of system is not there here. Okay, here the data maintenance is very difficult. Why? Because you are not storing the data in one system, you're storing in multiple systems. Okay, you don't know which system you'll be accessing. Okay, you have to maintain all this metadata related to that particular data. Okay, I'm storing employee data in this table, in this database, and this database also. That employee table metadata I have to maintain somewhere. That means the data maintenance is very tedious here, very difficult here. Okay, now based on this one, but the parallelism you can have more here. The performance is very, very, very better here. That's where Hadoop became very popular right nowadays. So because of parallelism only, since you're having more number of clusters here, more number of nodes here in a cluster, the more the size of the cluster, the more the performance, the more the parallelism I can say. That means you're adding the node here means you're adding a compute power there. You're adding more parallelism there. Okay, now Snowflake is following which type of architecture here? Is it following shared nothing architecture or is it following shared disk architecture? We have only one storage layer, that is centralized storage. Only we have one thing. That means it is taking advantage from this shared disk architecture, and we have unlimited compute power here. At any point of time, you can increase the compute power, you can decrease the compute power here. That means it is this property. It is taking from shared nothing architecture. That means it is not following the shared disk architecture. It is not following shared nothing architecture. It's a hybrid architecture, I can say. Okay, I told you, right? Compute and storage both are completely decoupled. Irrespective of the storage, you can increase the number of compute power. You can increase the compute power. Irrespective of the compute, you can increase the storage part also. Okay, both the advantages I'm taking from both the architectures and I'm combining into one, and I'm using the same thing in Snowflake. That's the beauty of Snowflake. Okay. Now, instant unlimited scalability. I told you, right? At any point of time, you can increase the number of servers or you can increase the number of clusters. At any point of time, you can decrease the number of clusters also based on the load or based on the number of users. That will happen automatically. That maintenance is done by Snowflake itself. Okay. Now, so what I wanted to tell you from this picture is I can access this particular data with different virtual warehouses. I can create dedicated virtual arrows only for the financial users. And I can create virtual arrows only for the enlist people. And I can create dedicated virtual arrows only for the reporting people. And whatever the hardware that you are using in this particular virtual arrows, that cannot be shared with any of the virtual arrows. And this hardware is dedicated to only this particular virtual arrows. And all the virtual arrows can access the data simultaneously without any conflict. Without any conflict. Okay, so this is the way we are getting more parallelism here. Any number of people can access the database parallelly. Any number of people. There is no concept of performance degradation. Okay, so that is one biggest advantage with Snowflake. Okay, and these are the different I can say comments from the different customers. You can go through these comments in the website. I've taken just 3 customers opinion and I've given here. Okay, and one more thing is with Snowflake you can connect with these tools with very easily. You can connect with Talent, you can connect with Tableau, you can connect with AWS, you can connect with the Looker, you can connect with Microsoft Azure, Matillion tool, Informatica, Fivetran, and Alteryx, whatnot. Every tool, not every tool. There are some tools which are partnered with Snowflake, I can say. Okay, there are some databases which are partnered with Snowflake. Okay, so those things you don't need to write. Say, let's say for example, I wanted to connect to Tableau. Generally, Tableau doesn't know who is Snowflake, and Snowflake doesn't know who is Tableau, right? They're completely both are independent here. But if at all, if you want to load the data, if you want to load the data in table and Tableau want to access the data, then connectors are directly available in Snowflake. The Tableau connectors are directly available in Snowflake. You don't need to write any connector program, and you can create integration between them. You don't need to do that one. Snowflake has written that code, and Snowflake has built that connector, and that is giving it to us. That is a good thing with Snowflake. You can connect with any of the reporting tool or any of the ETL tools and any of the clouds which are mentioned here. Not all the tools I'm saying. Okay. And initial days, whenever they came into market, Snowflake people, those that time in 2014 time, they they deployed their services only in AWS. They came up the cloud service on. Uh, they used to have only their services in AWS. Then after that, you guys know how the clouds are becoming popular day by day. And later on, this Azure also became very popular, and it started grabbing the market. Okay, and later on they came up, they deployed their services into even Microsoft Azure as well. That was happened in 2018 only. Okay, before that one, they have only they have their services only in AWS. Now 2018 June onwards, they started using Microsoft Azure as also one of the cloud provider. Okay, and later on they tied up with GCP as well, Google Cloud as well. So that's where this Snowflake is become popular. You can have your cloud in any of the public clouds. Like you can choose any of the cloud provider here, either AWS, Microsoft Azure, or GCP, whatever you want, based on your requirement. So let's say, for example, in your organization, they are using some Microsoft Azure tools like reporting, Power BI, and we have Alteryx tool is there, which is related to Microsoft Azure. Okay, if you're already using that one, but you wanted to store your data into Snowflake, of course you can choose cloud provider as Microsoft Azure, and you can create an account with that. Let's say, for example, I'm already using AWS, but I wanted to process, or I wanted to maintain one data lake with Snowflake. Then I can go ahead and create my Snowflake account with AWS. That is also fine. Or if you're already using, if you want to store the data into Snowflake with Google BigQuery, then you can go with that one also. So in any of the public cloud, you can create an account and you can utilize it. Okay. And one more thing is how the cloud providers are giving assurance to us in data in terms of data availability. The same assurance even Snowflake is also giving it to us, and this assurance is not really given by Snowflake. That assurance they are taking from cloud, and the same assurance they are passing it on to us. That's it. These people are not making sure the data availability. Okay, and that is provided by cloud itself. Okay, and whatever the data that you are storing in Snowflake, they are not storing in one availability zone. They are storing the data in three different availability zones. If this something happens to this particular availability zone, or some power issues came, or some internet issues came to this availability zone, generally that won't happen. But in case, worst case, if that is happening, if that happens to that particular availability zone, immediately you don't even know that you are switching to this availability zone. Snowflake is making sure that, and cloud providers are giving that assurance to us, and then they can immediately get the data from this availability zone. Or if this is also, if you have issue with this availability zone also, then they can immediately switch to this availability zone. Okay, and this is fully managed by Snowflake itself. We don't need to involve here. No administrator, no need to involve any involvement with administrator here. No involvement of administrator. They don't need to switch physically here. They don't need to connect to this availability zones. They don't need to worry about these availability zones. Okay. So, and one more thing is, one more beautiful feature that we have here in Snowflake is time travel. That is, time travel is nothing but in traditional databases. Let's say, for example, I have dropped one table by mistake. I did not intentionally do that one, but by mistake I have dropped one table. Okay, can we restore the data or can we retrieve the data immediately? No, right? Even in Oracle, if you take an example of Oracle, if you drop one table, of course, we have one flashing memory concept there in Oracle. So, but there is some time limitation there. Time limit means like within 1 hour you have to recover the data. Only admin can do that one. No developer can do that. Okay, if that 1 hour is passed, that's it. Your data is gone. You cannot retrieve it back. You cannot restore your data. But in Snowflake, that is not the case. Even if you drop it, your table is corrupted, some bad records came into your table, or some duplicates came into your table, no worries. You don't need to worry about that one. You can always go back. You can travel back and you can restore the table how it was there yesterday, or how it was there 20 days back, and how it was there 30 days back. You can get the state of the table very easily within fraction of seconds, within a single command. That's the very beauty with Snowflake. Even if you truncate the table, no worries. You can get it back. You updated by mistake, you updated like 100 records. Instead of updating 10 records, you updated by mistake 100 records. No worries. You can get it back. You can restore your data. That concept we call it as a time travel here. Okay. So, and one more thing is zero copy cloning. So, if at all, if you want to clone your database or schema or tables, okay, you can clone your objects very easily. With a single command, you can clone it. Okay, generally this is administrator will follow will do this activity, right? Even developers also can do this activity here. Okay, in traditional databases, they used to take the backup right after loads are completed. But here, with a single command, you can take the backup of any of the table, any of the schema, or any of the database. Okay, and if you replicate the data, let's say for example, in Oracle, if you're taking the backup, okay, then you have to take that backup into separate hard disk, right? Then you're maintaining data in two different places, right? Separate hard disk, you're maintaining the same data in hard disk and the original hard disk and the backup hard disk also. But here, you don't need to replicate the data. You have data in only one place, but you can still take the backup of that data without duplicating the data. That's the beauty of Snowflake here. That's where Snowflake is becoming popular nowadays. You don't need to have same data multiple places. Maintain the data in one place and try to have multiple clone parts. That we call it as a zero copy cloning. That we'll discuss anyway. Okay, and what types of file systems it supports? It supports structured data, that is CSV files, TSV files, .txt files, .dat files, and like any kind of structured files it supports actually. Okay, not only dat, not only text, not only dat, not only TSV, not only CSV. Any structured file it can support. It can take the data from those structured files. And coming to semi-structured, it can support JSON, Avro, Parquet, ORC, XML. Those things it can support. And it doesn't support unstructured data. Snowflake doesn't support unstructured data. We cannot process the data. Okay, so those are the file systems that it can support. And I told you, right, multi-cluster concept we have here, based on the load. If the load is more between 1 o'clock to 2 o'clock, so Snowflake will automatically increase the number of clusters and it can manage the load. If the load is very less between 2 o'clock to 3 o'clock, then based on that one, it can manage, then it can decrease the number of clusters and it can manage the billing part automatically without your intervention. Okay, that we call it as a multi-cluster warehouse. Multiple clusters it is going to invoke. Okay, that we will see whenever we get that topic. Okay, and data sharing. So this is also one of the good thing with Snowflake. I told you, right, live data we can share. So with other people, with other business people. Okay, so for that we are going to use sharing concept. So if you want, you can share your data with other account people. Let's say, for example, I have one Snowflake account with me and you're going to have one Snowflake account with you, and I can share the data with my account to your account directly. That we call it as a data sharing. So whatever the modifications I do in my database, in my table, that live data you can feel, you can get it directly. Okay, so that we call it as a data sharing. That is also one of the good thing with Snowflake. So this concept is not available in any other traditional databases. Okay, and we have cross-region data replication also. This is extended to I can say data sharing part. Okay, if you have data in Microsoft, if you have created Snowflake account with Microsoft Azure, you can still replicate the data. You can still share the data to the Snowflake account which is created with AWS. That we call it as a replication, cross-region replication. Okay, that is also possible with Snowflake. And I told you, right, in Snowflake, you don't need to have any special skills here. I told you, whatever normal traditional databases SQLs are supported, all those commands, 90% of the commands are supported in Snowflake. 90%. Okay, the only difference between the traditional database and the Snowflake is syntax will change here and there. That's it. The way of writing SQL is same as it is. The same way of table creation is same, update is same, insert is same, but syntaxes will change here and there. That's it, a little bit. 90% it is same as it is. That is the reason why I told you you have to have minimum knowledge in SQL. Okay, everything is supported here. And I'll show you the web UI also in some time after this 2 slides. Okay, history tab, everything I have given here. So this is the web UI of Snowflake, how the Snowflake is looking like. This is the thing. Okay, so this is the I can say web UI. So you can write your queries, you can query your data and you can analyze your data from here, or you can even load the data here, but that is limited data only we can do from here. Okay, I'll explain you which each and every component tomorrow. Okay, and you have to install this NoSQL also. This is the terminal where you're going to run your commands. Okay, you can run all your commands in WebUI also, but put command and get command are not supported in WebUI. So here, so that is the reason why you have to use this terminal to run that put and get commands. Okay, so except those 2 commands, everything is supported here in WebUI. Okay, or else you can have other tools also, that is DBviewer. I'll show you tomorrow how to install that one and how to configure your account with that. And I'll try to tell you how to create an account with Snowflake also tomorrow. Okay, so that is about demo part. So now you can ask your questions if you have any. And one more thing I wanted to discuss thing here, and if you, this is if at all somebody wants to, so if somebody is working on DBA activities like database administration kind of thing, if you want to switch your career to development thing, then of course you can come to this, you can learn this Snowflake and you can switch your career to development towards the development thing. Okay, and definitely this will become more and more famous, more and more popular, okay, in future, and it will be there till, I'm sure, I'm giving assurance it will be there next 5 years. So nowadays, like in market, every day one new tool is coming. Okay, I'm definitely saying Snowflake can compete all those things, and all those competitors can sustain in market till next 5 years, definitely. Okay, and learning is also very easy. If you follow my lectures every day, within 2 months or within 1.5 months you can become an expert. I'm giving that assurance, provided you have to follow my instructions. If you practice whatever I'm saying in the class as it is, you'll become an expert, I'm 100% sure. Okay, and nowadays you guys can see, if you open Naukri or some other job website, you can see lot of opportunities on Snowflake. Some of the guys know in this group already how the market is. Okay, and high pay scale. Nowadays, like we are getting more and more projects, but the people are Snowflake people are not there in the market. So if you learn now and if you get into the market, then you'll become the master. Now you can ask your questions. No questions?
Sir, please consider, is it possible to schedule the timing 7 to 8?
7 to 8:30. I'll
Yeah,
definitely take 1.5 hours actually. But till now I planned 9 to, sorry, 8 to 9:30.
8.
And if everyone is okay, then I can have the class at 7 to 8:30 also, no problem. I don't have any issue.
Most of the guys have work at 9 o'clock.
Okay.
It could be
Yeah, that's
better
fine.
for
It will
No
be
problem
useful
with me.
for US guys also.
Okay, no problem. I can do the same thing. I can follow the same timings. 7 to 8:30 is fine for me. If everyone is okay. Okay. Any more questions from anyone regarding the course or regarding content or regarding the Snowflake topics? Anything you can ask me.
What is the course duration, Chandra?
If we continue 1.5 hours for every day, I can close this course by within 1 month.
Okay. One and a half day every day, including
One and a half
the
hour, 1.5 hours every day means like within 1 month we can wind up.
including weekends or
Sunday, mostly Sunday, we will not be having any class till Saturday, Monday to Saturday.
okay, good. So, what are the prerequisites for this course?
I told you, right? SQL is the mandatory thing. You have to learn the SQL. So that
Is
SQL may be
basic.
anything. If you have any like Oracle knowledge, Oracle SQL knowledge, that is also enough. If you have any SQL Server knowledge, that is also enough. And if you have any DB2 knowledge, that is also enough. And if you have any Teradata knowledge, that is also enough. Any SQL. I'm not restricting to any of only Oracle. I'm telling you, you have to have the basic SQL. That's it.
Okay. What about Python and all?
Python, I told you, right? I'm not going to teach as part of this course, but I can guide you what are all the topics that you have to prepare. So lot of
Okay.
resources are there in YouTube actually. Nowadays, like everything is public. Public in the sense, every concept is available in YouTube. So I can tell
Yes,
you
sir.
what are the topics you have to prepare before you're before attending your interviews. And nowadays
So
everyone
that,
is asking Python as well in every interview. Then if you don't have knowledge in Python, at least you should manage that topics at least. Okay, then you'll be selected.
okay, sir. Because
Okay.
there are many things are there in Python.
Yeah, many things. You don't need to learn all those things in Python. That's what I'm doing. I can tell you what are all the topics that you have to prepare. So we have some
Okay,
topics
thank you, sir.
like loop, yeah, for loops, if loops. Let me go on mute, Nagesh. Yeah. We have some topics like loops are there, looping concept, if loop, for loop, and we have file handling concepts are there. How to open the file and how to close the file, and how to read the content from the file.
Okay.
Or how to access the environment variables like OS.environment concept. Those things you have to learn.
Yes. Hope you will give all the details, right?
Yeah, I'll give the details.
Okay, fine, sir.
Any more questions?
Here we are not doing anything with Informatica or data store, nothing like that, right?
Sorry, can you come again?
Here we are not doing any ETL activities with this Snowflake, right? I mean,
Partially we are going to do the same thing. Not complete ETL, but partially we are going to do the same thing.
so even anywhere we are going to develop ETL jobs like mapping, extracting, and all those.
Yes, we do that. We do that.
Okay.
Okay. That's it, guys. Still, if you have any questions, you can ask me, or we can wind up for the day.
Chana, can you stay online? I
Yeah,
want to share
yeah.
some error. Okay, I want to.
Okay. Sure.
Other people are dropped.
Okay. So tomorrow we can meet the same, like tomorrow at 7 o'clock we can meet, and 7 to 8:30 will be the class timings tomorrow, and we can try to we'll try to have class at 1.5 hour from tomorrow onwards. And I'm giving the chance to each and everyone, and you don't need to pay any single rupee for me now, right away, and you can attend for 3 to 4 sessions. And if you like the sessions, then you can continue, or you can drop off later after 3 to 4 classes. So you don't need to pay anything for me now. Okay.
Okay. Thank you.
Yeah.
Um,
Yeah. Let me stop recording the session.